Do you believe that just 124 light-years from Earth there may exist a planet holding our strongest hope for discovering life beyond our world? K2-18b has come into focus through data from the James Webb Space Telescope revealing traces of dimethyl sulfide, a molecule on Earth that is almost exclusively associated with ocean-based biological systems. Although this signal has not yet reached the level of scientific certainty required to confirm life, it is unusual enough to support a serious hypothesis about the presence of liquid oceans and potential biological activity beyond Earth. From this point, a broader picture of exoplanets emerges marked by extreme conditions, worlds locked between eternal day and night skies that rain molten metals, supercritical oceans, diamond-compressed planets, and giant systems with orbits stretching hundreds of thousands of years. In a universe that is largely hostile and indifferent to life, K2-18b stands out as a compelling exception, suggesting that life may not be a solitary miracle. Next, we will follow James Webb deeper into K2-18b to explore whether this world could be a true second Earth or even a planet that genuinely hosts life. The silence in the control room is heavy, the kind that precedes a verdict. A dozen astrophysicists are huddled around a bank of monitors waiting for a transmission that has travelled 124 light-years across the void. That is 730 trillion miles of freezing darkness. High above the atmosphere, floating at Lagrange Point 2, the James Webb Space Telescope has just concluded a deep field stare at a faint red ember in the constellation Leo. The data packet decodes on the main screen. It is not a photograph of blue oceans or green continents. It is a spectrum, a jagged, chaotic line of white noise trembling against a black background. To the uninitiated, it looks like static. To the forensic experts in this room, it is a fingerprint. They are looking for a specific chemical suspect, dimethyl sulfide DMS. On Earth, this gas is the pungent breath of the sea, produced almost exclusively by living things like phytoplankton and marine microbes. It is a molecule that shouldn't be there. It is unstable and decomposes rapidly under sunlight. It cannot survive in an atmosphere for long, unless something is constantly actively replenishing it. The initial detection in 2023 was a shock, registering a probability of 99.7% or 3 sigma confidence. In a court of law, that is a conviction. But in the ruthless court of astrophysics, where light can be distorted by a billion variables, it is merely a lead. To officially declare the discovery of alien life science demands 5 sigma, 99.99994% certainty or less than 1 chance in a million that the data is a fluke. Isolate the signal, the lead researcher murmurs. The algorithms go to work stripping away the blinding glare of the host star, the red dwarf K2-18. The jagged line trembles and smooths out. There, buried in the infrared noise, the absorption dip remains. It is faint, a ghost in the machine, but it implies a concentration of biological gas 1,000 times higher than found on Earth. If this is not a mistake, we're not just looking at a rock, we are looking at a thriving ocean. To understand the gravity of this moment, one must understand the method. We cannot see the planet itself. It is swallowed by the glare of its star, but every time K2-18b transits passes in front of its sun, a tiny fraction of starlight filters through the planet's atmospheric rim. This is transmission spectroscopy. The atmosphere acts as a colossal lens, absorbing specific wavelengths of light depending on the gases present. To the instruments on the James Webb Space Telescope, these missing photons are the forensic evidence. They form absorption lines, a chemical barcode that reveals the identity of the air. However, the investigation is plagued by a problem known as spectral degeneracy. In the near-infrared range, initially scanned the fingerprint of dimethyl sulfide looks dangerously similar to that of methane. A slight calibration error could misidentify a common gas as a biological miracle. This is why the initial detection made with a single instrument was treated with extreme caution. Currently, the detection stands at a statistical significance of 3 sigma. In the language of probability, this means there is a 99.7% chance the signal is real. While this sounds high, it leaves a 0.3% margin for error, roughly a 1 in 370 chance that the data is just noise. In the high-stakes arena of history, that is not enough. To claim the discovery of alien life science demands the gold standard of 5 sigma. This requires a confidence level of 94%, leaving only a 1 in a million chance of error. This was the same rigorous threshold required to confirm the existence of the Higgs boson in 2012. Until the data crosses this line, the researchers at Cambridge remain paralysed between hope and scepticism, knowing that K2-18b is either the greatest discovery of all time or a cruel cosmic illusion. To understand the potential source of this signal, we must first understand the stage upon which this drama unfolds. K2-18b is not a second Earth. It is a world that defies the neat categories of our solar system. Located 324 light-years away in the constellation Leo, it orbits a cool red dwarf star K2-18, which is far smaller and dimmer than our Sun. Because its star is so faint, the planet must hug it tightly to stay warm. K2-18b orbits closer to its star than Mercury does to the Sun, completing a year in just 33 days. Yet this proximity places it exactly in the habitable zone, receiving roughly the same amount of solar energy as Earth. Physically, however, it is a Titan. K2-18b is a sub-Neptune, nearly 2.6 times the radius of Earth and roughly 9 times as massive. Standing on its surface, if a surface exists, gravity would feel punishingly heavy. But the true anomaly lies in its composition. Scientists have classified K2-18b as a Hycean world, a portmanteau of hydrogen and ocean. Imagine a planet with no continents, no islands, no shallow coasts, just a single global ocean that stretches from pole to pole, potentially hundreds of kilometers deep. Above this endless water sits a crushing thick atmosphere dominated by hydrogen. The view from this alien ocean would be surreal. Due to the dense hydrogen haze scattering light, the sky would likely not be blue, but a turbid glowing orange or milky white illuminated by the crimson glare of the red dwarf sun. The evidence for this ocean is compelling. The James Webb Space Telescope detected abundant methane and carbon dioxide, but crucially it found no ammonia. In a gas giant atmosphere, ammonia should be everywhere. Its absence suggests a massive liquid water reservoir is acting as a scrubber, dissolving the ammonia into the depths. On paper, it sounds like an aquatic paradise. But in astrophysics, the difference between a warm bath and a boiling pressure cooker is terrifyingly small. However, not everyone is convinced that K2-18b is an oasis. An active and fierce debate is currently dividing the astronomical community. Is this planet truly a Hycean water world, or is it merely a mini Neptune, a gaseous dwarf with no surface at all? Dr. Nicholas Vaughan of NASA's Ames Research Center represents the skeptical faction. He argues that K2-18b might simply be a miniature gas giant. In this scenario, the planet is not covered in an ocean, but is wrapped in an incredibly thick envelope of hydrogen and helium that gets denser and hotter the deeper you go. There would be no splashdown, no liquid surface, only a transition into a crushing superheated fluid, and eventually a rocky core buried under layers of gas thousands of kilometers thick. If this is the case, the chances of life vanish instantly. Biology as we know it cannot organize in a void without a surface. The counter-argument, led by Professor Nikku Madhusudhan of Cambridge University, relies on the chemical fingerprints found in the atmosphere. The key evidence is the mysterious absence of ammonia. On a gas giant like Neptune, ammonia is abundant. On K2-18b, it is missing. Madhusudhan's team posits that the only logical sink for this ammonia is a massive liquid water ocean, which would dissolve the gas and scrub it from the atmosphere. But even if the ocean exists, it faces the threat of a runaway greenhouse. A thick hydrogen atmosphere is an incredibly efficient thermal blanket. It traps heat. Critics warn that the greenhouse effect on K2-18b could be so intense that the ocean is not liquid water, but a boiling supercritical steam bath where temperatures and pressures turn the environment into a sterilized inferno. So we are left with a binary reality. K2-18b is either a sterile pressure cooker wrapped in gas, or it is a warm liquid miracle surviving against the odds. If the latter is true and the temperature is just right, then that global ocean becomes the perfect stage for the unthinkable. If the ocean exists, and if the temperature is survivable, we are faced with the most staggering question of all. What is making the gas? On Earth, dimethyl sulfide is not a random byproduct. It is part of a sophisticated biological feedback loop known as the Claw hypothesis. Marine phytoplankton produce DMS to help seed clouds, which in turn reflect sunlight and cool the planet. If the signal from K2-18b is biological, the life forms there might not just be passive residents. They could be planetary engineers pumping out massive quantities of gas to create a cloud shield that prevents their world from boiling over. The concentration detected is colossal, 1,000 times higher than on Earth. This suggests a biomass of immense scale. But what would these creatures look like? Evolution on a Hycean world would follow different rules. Without sunlight penetrating the deep hydrogen haze, vision would be useless. Primary producers would likely rely on chemosynthesis, deriving energy from the chemical soup of the ocean rather than the sun. The physical constraints are equally alien. The pressure at the bottom of a Hycean ocean could be thousands of times greater than Earth's atmospheric pressure. To survive, organisms would need to abandon air pockets, which would be instantly crushed. Instead, we might expect creatures with dense, gelatinous bodies like massive versions of Earth's jellyfish drifting through the dark, warm currents. Alternatively, they might develop armour. Evolution could favour cartilaginous skeletons or flexible, high-density exoskeletons capable of withstanding the crushing weight of the deep. In an atmosphere lighter than nitrogen but thicker in volume, buoyancy changes. Hydrogen is light, meaning the lift provided by the medium is different, potentially allowing for the evolution of truly gigantic, slow-moving leviathans that would collapse under their own weight on Earth. Whether they are microscopic algae regulating a global thermostat or armoured giants patrolling a sunless sea, the mere possibility of their existence forces us to rewrite our definition of habitable. While K2-18b offers a shimmering hope, the vast majority of exoplanets discovered around red dwarfs face a much darker, more rigid destiny. This is the realm of the tidally locked worlds caught in an eternal gravitational stare. Take Teegarden B, a neighbour located just 12.5 light-years away, or Kepler 1649c, an Earth-sized world sitting 301 light-years deep in the Cygnus constellation. On paper, they are prime candidates for habitability with radii, and masses comforting similar to our own. But in reality, they are prisoners. Because these planets orbit so close to their dim host stars to stay warm, gravity acts as a relentless brake on their rotation. Over millions of years, the star's gravity slows the planet's spin until it matches its orbital period exactly. The result is a world where time has effectively stopped. There is no sunrise, there is no sunset. The planet rotates exactly once every year, keeping one face permanently directed at the star and the other hidden in forever darkness. This configuration creates a terrifying physical threat known as atmospheric collapse. On the permanent night side, without the kiss of starlight, temperatures can plunge so low that the atmosphere itself ceases to be a gas. Nitrogen and carbon dioxide may freeze solid, turning into snow and falling to the surface. As the gas condenses, it lowers the pressure, creating a vacuum that sucks more air from the day side over to the night side, where it too freezes and falls. In this scenario, the planet effectively vacuums up its own sky, leaving it naked, frozen and dead. These are the eyeball planets worlds that look like a giant unblinking eye staring into the fire. For decades, astronomers feared these worlds were all graveyards. But new climate models suggest that a narrow strip of land might survive the freeze if you know where to walk. Imagine standing on the surface of Teegarden B. You're not in a spaceship, you're in an exosuit, boots on the ground, navigating the most precarious footpath in the universe, the Terminator line. This is the Twilight Zone, the razor-thin border between the eternal day and the endless night. If you look to the east, the star, a bloated crimson eye, hangs motionless on the horizon. It will never rise, it will never set. The landscape ahead is bathed in a perpetual ruddy sunset. To your left, the dayside stretches out into a scorching wasteland. Temperatures here can soar to 50 degrees Celsius or higher, baking the rock and evaporating any water instantly. To your right, just a few kilometers away, lies the night side. It is a kingdom of shadow where temperatures plunge far below freezing, locking water into ice seemingly harder than granite. You're walking the only survivable line. But this is no peaceful stroll. The physics of this world creates a violent engine. The atmosphere on the hot side expands and rises while the air on the cold side contracts and sinks. This pressure difference drives fierce, relentless winds, super-rotating storms that scream across the Twilight Zone, attempting to redistribute the heat. The wind pushes against your back, carrying the heat of the day toward the freezing dark. If this planet has water, this is the only place it can exist in liquid form. You might see rivers of meltwater flowing from the edge of the night glaciers, only to boil away into steam as they cross into the day. Life here wouldn't be everywhere. It would be huddled in the cracks of this twilight storm, clinging to the fragile equilibrium between fire and ice. Yet amidst these frozen graveyards and storm-racked twilight zones, there is one candidate that stands apart, a beacon of genuine hope. Located 101 light-years away in the southern constellation of Dorado lies TOI 700d. Discovered in 2020, this world offers something that its cousins Teegarden b and Kepler 1649c likely cannot: the rhythm of time. Unlike the vast majority of planets orbiting red dwarfs, models suggest that TWI 700d may not yet be tidally locked. It is possible that this planet still spins, maintaining a regular cycle of day and night. This single dynamic changes everything. Instead of a bifurcated world of eternal fire and ice, TWI 700d could have a global climate, with winds and weather patterns that distribute heat evenly across its surface. The conditions here are tantalizingly familiar. The planet receives about 86% of the sunlight that Earth gets from the Sun. While initial calculations place its surface temperature at a chilly 4 degrees Celsius, this is not a death sentence. With even a modest greenhouse effect provided by an atmosphere, those temperatures could easily rise into the range of liquid water. Furthermore, the host star itself is an anomaly. Most red dwarfs are violent, volatile parents constantly lashing their children with sterilizing solar flares. TWI 700, however, appears to be remarkably quiet. It does not bombard its system with the powerful storms that strip away atmospheres, increasing the probability that TWI 700d has retained its air, its oceans, and perhaps its potential for life over billions of years. If the twilight zone requires life to be a desperate survivor clinging to the edge, TWI 700d invites life to flourish. It is the closest thing to an oasis we have found in the red dwarf desert. But as we leave the habitable zone, the universe is about to show us that Earth-like is the exception, not the rule. As we leave the delicate, hopeful oases of the habitable zones, the universe reveals its true violent nature. Most planets are not cradles for life. They are engines of destruction. And nowhere is this industrial horror more palpable than on WASP 76b. Located 640 light-years away in the constellation Pisces, this ultra-hot Jupiter is a world screaming in agony. Like the red dwarf planets, it is tidally locked, forced to show one face eternally to its star. But unlike them, WASP 76b orbits so close that its dayside is not just hot, it is being incinerated. Temperatures on the sunlit hemisphere soar to a staggering 2,350 degrees Celsius. This is hot enough to vaporize lead melt rock and even break molecules apart. The radiation is thousands of times more intense than what Earth receives from the Sun. In this blast furnace, even iron, the backbone of heavy industry, cannot exist as a solid. It surrenders to the heat, evaporating into a metallic gas. The atmosphere here is thick with atomic iron vapor, invisible and searing. But the horror lies in the transport mechanism. Because the night side is permanently turned away, it is drastically cooler, though still a scorching 500 degrees Celsius. This extreme thermal gradient creates a pressure difference that drives ferocious global winds. These winds act like a conveyor belt, whipping the iron-rich atmosphere from the day side to the night side at hypersonic speeds. As the iron vapor crosses the terminator line into the shadow, the temperature drops below the condensation point. The gas liquefies. The sky turns heavy and dark, not with water clouds, but with clouds of molten metal. And then gravity takes over. On the night side of WASP 76b, it rains iron. Imagine standing in that storm. The sound would be deafening, the hiss of cooling metal and the roar of the wind. Drops of liquid iron glowing lethal red fall from the sky, splattering onto the surface with the force of bullets. This is not weather. It is a planetary-scale munitions factory recycling its own surface into an endless bombardment. If WASP 76b is the foundry of hell, GJ 1214b is its crushing abyss. Located about 40 light-years away, this exoplanet is a sub-Neptune, with a mass more than 8 times that of Earth. Early observations led to it being dubbed a water world, a name that evokes images of a global ocean potentially teeming with life. But this moniker is a cruel deception. GJ 1214b is a trap disguised as an oasis. The horror of this world lies in its state of matter. On Earth, we're used to clear distinctions. The ocean has a surface and the air is a gas. You can splash into the water, you can breathe the air. On GJ 1214b, these boundaries are erased by violence. The planet possesses an incredibly thick atmosphere that traps heat, driving the ambient temperature to a searing 280 degrees Celsius. Under normal circumstances, water at this temperature would boil away into steam. But here the atmospheric weight is so colossal that it acts like a planetary-scale hydraulic press. The immense pressure forces the water into a state that is neither liquid nor gas, but a terrifying hybrid known as a supercritical fluid. Imagine descending into this atmosphere. There is no horizon to see. The light from the star is diffused into a thick, glowing grey fog. There is no splashdown. As you descend, the air simply becomes denser and denser, thickening imperceptibly from a mist into a sludge, and finally into a crushing fluid. You would be swimming in a medium that flows like a gas but dissolves materials like a liquid. Scientists describe this as water in a strange plasma form. It is a world without a bottom, a gradient of increasing density that eventually transitions into high-pressure ice, not cold ice, but hot ice event, solid water formed solely by the crushing weight of the world above. In this supercritical abyss, biology as we know it is impossible. There is no chemistry here, only physics pressing down with the weight of an entire planet. The universe has one final circle of hell to show us, and it is not defined by rain or pressure, but by resurrection. In the constellation Cygnus, about 650 light-years away, orbits a world that should be dead, Kepler 70b. This is a Chthonian planet, a ghost world. Once it was likely a gas giant the size of Jupiter, majestic and cold. Today it is a shriveled ember, a rock smaller than Earth, 0.44 Earth masses spinning frantically around its star. But the horror of Kepler 70b is not its size, it is its temperature. The surface of this planet burns at a mind-bending 650 degrees Celsius. To put that number in perspective, the surface of our own Sun is only about 500 degrees Celsius. If you could stand on Kepler 70b, the ground beneath your feet would be hotter than the star burning in the Earth's sky. It is quite literally hell on Earth. How does a planet become hotter than a star? The answer lies in a violent history that unfolded about 18.5 million years ago. The host star Kepler 70 reached the end of its life and expanded into a red giant. As it ballooned outward, it swallowed Kepler 70b whole. For a significant period, this planet orbited inside the belly of its dying star. It ploughed through the stellar plasma, the friction stripping away its thick atmosphere and boiling off its oceans, leaving only the indestructible searing iron core. Somehow, it survived. The star eventually shed its outer layers to become a tiny hot subdwarf, revealing the burnt survivor left behind. Now Kepler 70b orbits so close, 65 times closer than Mercury is to the Sun, that it completes a year in just under 6 hours. It is still evaporating, a dying ember slowly turning into dust. It serves as a grim reminder that in the cosmos, survival is just a slower form of extinction. If the previous worlds were defined by fire and pressure, our next destination is defined by a singular crushing density. In the constellation Serpens Carda, orbiting a dead star, lies a treasure that defies human valuation. PSR J7719-1438b. This is not a rock. It is for all intents and purposes a planet-sized diamond. To understand how such a jewel comes into existence, we must look at the violent history of its parent star. The host is not a normal sun. It is a millisecond pulsar, a neutron star only 20 kilometers across, spinning at a terrifying rate of 10,000 rotations per minute. A teaspoon of its material would weigh billions of tons. It is a cosmic lighthouse sweeping beams of radiation across the galaxy every 5.4 milliseconds. But this pulsar was not always alone. Once it had a companion, a white dwarf star. In a binary dance of death, the massive gravity of the pulsar began to cannibalize its partner. It stripped away the white dwarf's outer layers of hydrogen and helium, feeding on the stellar material to spin itself up to frantic speeds. What remains today is the corpse of that victim star. It is no longer a star, but it is too massive to be a standard planet. It retains a mass slightly greater than Jupiter, yet it has been squeezed into a diameter just 40% the size of the gas giant, or roughly 5 times the size of Earth. This discrepancy between mass and size implies a density that is off the charts. The planet is so dense that it cannot be made of hydrogen or helium. It is composed almost entirely of carbon and oxygen. Under the immense crushing pressure of its own gravity, this carbon is believed to have crystallized. Imagine a crystal lattice structure extending for thousands of kilometers. This world is likely a single continuous diamond of unimaginable purity. But there is no beauty here, only physics. Orbiting just 600,000 kilometers from the pulsar, close enough to fit inside our Sun, the diamond planet is blasted by high-energy radiation. It is a glittering radioactive tombstone, a monument to the star that was eaten alive to create it. If the diamond planet is a monument to density, our next destination is a monument to sheer unadulterated scale. In our own solar system, Saturn is the undisputed jewel, adorned with a ring system that has captivated humans since Galileo, first pointed a telescope at the sky. But in the grand context of the cosmos, Saturn is merely wearing a costume jewelry ring. The true Lord of the Rings resides 434 light-years away in the constellation Centaurus J-47b. Astronomers have dubbed this object Super Saturn, or more colloquially Saturn on steroids. The planet itself is a colossus estimated to be between 10 and 40 times the mass of Jupiter, placing it on the fuzzy border between a gas giant and a brown dwarf star. But the planet is dwarfed by its own halo. J1407b is surrounded by a ring system of terrifying proportions. It consists of 30 distinct dense rings spanning a total diameter of 120 million kilometers. To put that number into perspective, this ring system is 200 times larger than Saturn's. It is so vast that if you replace Saturn with J1407b in our own solar system, the rings would not just be a point of light, they would dominate Earth's night sky. They would appear larger than the full moon, spanning from horizon to horizon, a glowing silver arch visible even during the day. But this structure is not just a decoration, it is an eclipse engine. When J1407b passes in front of its star, it doesn't just block the light for a few hours like a normal planet. The eclipse lasts for weeks. The star flickers and dims erratically as its light struggles to punch through the millions of kilometers of dust and rock. However, this majesty is likely fleeting. Astronomers believe we are witnessing a specific temporary epoch in the planet's life. These rings are essentially a massive construction site, a circumplanetary disk where dust is slowly clumping together. Over the next few million years, the rings will thin out and vanish, condensing to form a retinue of moons. We are lucky to have caught this celestial giant in its most flamboyant phase before gravity cleans up the mess. The universe, however, does not only traffic in the horrific or the colossal, sometimes it seems to indulge in the absurd. If the diamond planet represents the ultimate crushing density, its polar opposite can be found in the cotton candy world of WASP-107b. Located in the constellation Virgo, this planet presents a paradox that kept astronomers awake at night. In terms of sheer volume, WASP-107b is roughly the size of Jupiter. But when scientists measured its mass, they found it to be shockingly light, only about 30 times the mass of Earth, whereas Jupiter is 300 times as massive. This gives WASP-107b a density comparable to a marshmallow. If you could find a bathtub large enough to hold it, this planet would float. Its existence challenges our models of planetary formation. Standard theory dictates that to build a gas giant, you need a massive rocky core at least 10 times the mass of Earth to attract that much gas. But WASP-107b has a tiny core barely 4 times Earth's mass. It is a puffed-up cosmic souffle, a balloon of gas held together by gravity so weak that its atmosphere is constantly bleeding into space. But if WASP-107b is a textural anomaly, GJ504b is an aesthetic one. Located 57 light-years away, this gas giant is 4 times more massive than Jupiter, yet it is famous for its colour. It is not the usual deep blue of Neptune or the striped beige of Jupiter. GJ504b is pink. To the human eye, it would appear as a glowing orb of dull magenta or cherry blossom. This coloration is not due to a strange chemical dye, but to youth. The system is only about 160 million years old, a mere infant compared to our 4.5 billion-year-old solar system. The planet is still radiating the intense heat of its violent formation. It is essentially a cooling ember, and at a temperature of about 237 degrees Celsius, its thermal glow peaks in the infrared, but bleeds into the visible spectrum as a deep radioactive pink. It is a reminder that planets are not static sculptures. They are evolving bodies that change their face as they age. As we push the boundaries of our investigation, we encounter a world that challenges the very definition of a solar system. In the vast silent gap between the stars, loneliness is the default state. But for the planet known as 2-mass J2126, loneliness is a defining physical feature. For years, astronomers believed this object was a rogue planet, a cosmic orphan that had been ejected from its home system and condemned to wander the galactic void alone. It floated in darkness, untethered to any sun. But in 2016, a team of researchers noticed something peculiar. A star named T-Forest 9486 99271 was moving through space in the exact same direction and at the same speed. They were not strangers, they were a family. But the distance between them shattered our understanding of gravitational mechanics. 2-mass J2126 orbits its star at a staggering distance of 1 trillion kilometers. To put that number into human terms, it is 7,000 times the distance between the Earth and the Sun. If you were to stand on the surface of this planet, you would not see a sun. You would see a bright, piercing dot in the night sky, indistinguishable from other distant stars to the naked eye. The bond of gravity here is so tenuous, so fragile, that the light from the parent star takes over a month to reach the planet. This enormous orbit creates a calendar that defies comprehension. On Earth, a year is 365 days. On 2-mass J2126, a single year, one trip around its star lasts approximately 900,000 Earth years. Civilizations on Earth could rise, fall, and be forgotten. Ice ages could come and go. Humanity could evolve from stone tools to interstellar travel, all in the time it takes this lonely world to complete a single season. It is the largest orbital radius of any planet known to science, a testament to the terrifying reach of gravity. It reminds us that a solar system is not just a huddled campfire of planets seeking warmth. It is a vast invisible web stretching across the dark. As we step back from the eyepiece and look at the gallery of worlds, we have discovered a chilling pattern emerges. We have seen planets that rain molten iron worlds compressed into diamonds, and lonely wanderers lost in the eternal dark. These are not anomalies, they are the standard. The universe, it seems, is violent, chaotic, and overwhelmingly hostile. This backdrop of cosmic violence is what makes the faint trembling signal from K2-18b so profound. For decades, scientists have debated the rare Earth hypothesis, the idea that while planets are common, the specific convergence of conditions required for life is a statistical miracle. To win the cosmic lottery, a planet must dodge 1,000 bullets. It needs a stable star that doesn't sterilize it with flares. It needs a magnetic field to shield its atmosphere. It needs to be in the Goldilocks zone, not too hot, not too cold. It needs the right mix of water and rock. Most of the time, the wheel of planetary formation spins and lands on magma, ice, or gas. We are the result of that wheel landing on blue. The discovery of K2-18b tests the very foundation of this hypothesis. If we find life just 124 light-years away, a mere stone's throw in a galaxy spanning 100,000 light-years, it implies that the lottery is rigged in favor of life. It would mean that Earth is not a solitary miracle in a graveyard of failed worlds, but part of a vast hidden archipelago of living islands. But until that confirmation comes, we must look at our own blue marble with a renewed sense of awe. We are the survivors of a 4.5 billion year game of Russian roulette. The monsters we see in our telescopes, the iron rains and the plasma oceans, are the ghosts of the worlds that lost the game. The verdict is not yet in. As you read this, the James Webb Space Telescope continues its silent vigil, collecting photon after photon, slowly filling the statistical gap between 99.7% and 99.9994%. Professor Madhusudan and his team estimate that within the next 2 years the data will be undeniable. We are standing on the precipice of a Type 1 civilization moment, the first time a species confirms it is not the only consciousness in the dark. But consider the geography of this discovery. K2-18b is located 124 light-years away. To a human, that distance is insurmountable, a voyage of millions of years with current technology. But to the universe, which stretches across 93 billion light-years, 124 light-years is not distant. It is our immediate backyard. It is the spare room in our own apartment. If we find life this close on a planet this strange, the implications are staggering. It would suggest that the emergence of life is not a miraculous accident that happens once in a galaxy, but a robust imperative that happens everywhere. It would mean that every star you see in the night sky potentially hosts eyes looking back at you. However, if the data clears and the signal vanishes, if K2-18b turns out to be just another sterile gas-choked tomb, the silence will be deafening. It will force us to confront the possibility that we truly are the only ones holding the torch of consciousness in an infinite theatre of rock and fire. Either way, the answer is coming. Humanity has spent its entire history looking up, asking, are we alone? We are the first generation that might actually get a reply. The universe is no longer just a backdrop of myths and constellations. It is a physical place waiting to be read. And somewhere in the noise between the iron rains and the diamond worlds, a signal is waiting to be heard. As we pull back from the eyepiece of the James Webb Space Telescope and let the gallery of alien worlds fade into the black, a chilling realization settles in. Our journey through the cosmic archipelago has not been a tour of potential homes, it has been a tour of graveyards. We have witnessed the industrial violence of WASP 76b, where the skies rain molten iron. We have descended into the crushing supercritical abyss of GJ 1214b. We have stood in the shadow of the lonely wanderer 2MASS J2126, drifting in the eternal cold. The universe, it seems, is not built for us. It is violent, chaotic, and overwhelmingly hostile. The default state of the cosmos is not the gentle lap of ocean waves, it is the roar of radiation and the crush of gravity. This backdrop of cosmic violence is precisely what makes the faint trembling signal from K2-18b so profound. It acts as a single flickering candle in a dark room. For decades, the scientific community has been haunted by the rare Earth hypothesis, the terrifying mathematical probability that while planets are common, life is a statistical miracle. To win the cosmic lottery, a world must dodge 1,000 bullets, solar flares, atmospheric collapse, runaway greenhouse effects, and orbital chaos. Most of the time, the wheel of planetary formation spins and lands on fire, ice, or gas. We are the anomaly. We are the result of the wheel landing on blue. But the discovery of dimethyl sulfide on K2-18b challenges the very foundation of this loneliness. If we confirm the existence of life just 124 light-years away, a mere stone's throw in a galaxy spanning 100,000 light-years, it implies that the lottery is rigged. It would suggest that the emergence of life is not a miraculous accident that happens once in a billion years, but a robust chemical imperative that erupts wherever the conditions allow. It would mean that Earth is not a solitary miracle in a universe of dead rocks, but part of a vast hidden chain of living islands waiting to be mapped. Yet the verdict is not yet in. The difference between the current 3 sigma confidence and the required 5 sigma certainty is the difference between a hunch and a fact. As you read this, astronomers at Cambridge are sifting through the noise, waiting for the data to tip the scales. We are standing on the precipice of a Type 1 civilization moment, the first time a species confirms it is not the only consciousness in the dark. Consider the geography of this moment. To a human, 124 light-years is an insurmountable distance, but to the universe it is our immediate backyard. If we find life this close, it means the galaxy is teeming. It means that every star you see in the night sky is a potential sun to someone else's world. However, if the signal fades, if K2-18b turns out to be just another sterile gas-choked tomb, the silence will be deafening. It will force us to look at our own blue marble with a terrified, renewed awe, realizing that we may truly be the only ones holding the torch of consciousness in an infinite theatre of rock and fire. Either way, the silence is ending. Humanity has spent its entire history looking up, shouting into the void, asking, "Are we alone?" We are the first generation that might finally get a reply. The universe is no longer just a backdrop of myths and constellations. It is a physical place waiting to be read. And somewhere in the static between the iron rains and the diamond worlds, the answer is waiting. Ultimately, the James Webb Space Telescope does not just act as a window into the deep past. It acts as a terrifying mirror. By studying the monsters of the cosmos, the iron furnaces of WASP 76b, the diamond tombs of pulsars, and the lonely wandering stars, we are learning to define ourselves by what we are not. We are not crushed by gravity. We are not dissolved by supercritical oceans. We are not stripped by stellar winds. This is the true value of the K2-18b investigation. Whether the signal resolves into the signature of life, or fades into the noise of a sterile ocean, the discovery has already changed us. It has shattered the illusion that habitable is a binary state. We now know that the universe is filled with almost Earth's failed experiments and horrifying exotic states of matter. If the data eventually confirms that we are alone in this sector of the galaxy, it imposes a heavy burden upon our species. It would mean that Earth is not just a planet but a sanctuary, the only vessel of consciousness in a sea of violent, mindless matter. It would mean that we are the universe's only way of experiencing itself. But if the signal is real, if that faint dip in the light spectrum truly belongs to biological dimethyl sulfide, then the silence of the night sky is an illusion. It means that across the gulf of 124 light-years something is breathing. The hunt is no longer science fiction, it is a forensic reality. The photons are already in the telescope's mirrors, the data is already on the servers. We're just waiting for the math to catch up with the truth. Until then, we keep watching, knowing that somewhere in the vast cold archive of the night, a second heart might be beating.